This recording. All right. So here is ASCII. If you haven't used ASCII before, it's an old-fashioned system of encoding characters as numbers. It only handles English, which is a serious limitation, but aside from that, it's a fine technique. And so you'll see here capital A is 65 in decimal, which is 41 in hexadecimal, because that's 4 16s plus 1. And then it's just in order A, B, C, D, E, just goes up by 1. The lowercase letters are later over here, and you have numbers and symbols and stuff. So every typewritten character can turn into a single byte value here. That's ASCII. So in Python, it's a bytes object. So if I make a B, then I'm making a byte object. So this is not a string ABC, it's a byte object ABC, 3 bytes. And I can pick one byte out with square brackets. So A square bracket 0 will give me the first byte in there, and I can print it out. So ABC is bytes, A0 is int. And I should have printed A sub 0 here. It looks like a typo. That would make more sense. That'll give me the actual value of A0. And A sub 0 is 65. That's the numerical value of capital A in base 10, and it's class integer. And now I can add another byte to the byte array, and now it'll be ABCD. And then if I try to change the second value, A sub 1, to D, now it's going to complain and tell me you cannot support item assignment. Bytes are what's called immutable. Now you can add something to it because that creates a new object and puts it in the variable, but you can't change part of it. Not this way. So that's a thing to know about Python. Now if you wanted to actually do this, just change the second element of the array, what you'd have to do, you can do it, but you have to do it this way. You have to basically create a new object. So what you could do is you could set B equals to A sub 0 plus bytes of D plus A sub 2 to the end. And that should do it, I think. If I print B, this is a way I can take part of the first array, put in a new value, and put in the rest of the first array. So I can build something that's going to be but yeah, I'm supporting integer and bytes. I see this is still a bytes array. This is an individual element. So I guess I need to make it bytes. And this is like I say, in Python, I spend a lot of my life changing things from one variable type to another. Yep, that now works, I think. Well, it didn't work too well, did it? No, that made... Yeah, so I'd have to look into this. How do I make... Let me just try to solve this one while we're here. It's a good example. Okay, how do I make a byte object containing only the first byte of another bytes object? And you don't have to spell it too well. The AI will figure it out. And it's probably going to figure out I mean Python. Original bytes 0:1. Oh, that's it. Use 0:1 instead of just 0. That will give you the, so that should do it. If I just make this 0:1, then it'll be a bytes object because it could have been more than one byte. That looks pretty good. Let's try that. Yep, there we go. Now I get ADCD. I managed to change the second byte, but I didn't actually change it in variable A. I had to build a new structure and give it another name. Well, I could, in fact, call it A again. That would replace the old A with a new A. But as you can see, you have to be sort of careful and explicit. You don't actually change a value in the middle of a byte object. You create a new byte object from pieces of the old one. All right, good. All right, and then there's byte arrays. Here. Byte arrays are different than bytes objects because they are mutable. So let me just make another code block here because we might need to compare these two. Now I make a byte array containing ABC, and I print it out. So now it's byte array. This is class byte array. It's ABC. And now you can set this first value to a different number, like ADC, and it takes it. So byte arrays are mutable. Bytes are immutable. A strange property of Python. And then you got unprintable characters. So here I'm going to make an empty bytes object. A is B, quote, quote. Then I'm going to print A and type of A, and I'm going to take the integer and convert it into bytes. All right, let's see what happens. So 1 to 5, and I print A, type. All right. The plus equals is what I missed. So I start with an empty byte object, and then I add a bytes based on these numbers, a big endian. So it's going to add those numbers in order, starting at 65, which is capital A, and then going 66, 67, 68, which is A, B, C, D, E. Now here, I'm going to do int2 bytes of just numbers from 5 to 10, and what you'll see is this entire construction, \x05 is 1 byte. That's how it expresses a non-printable character. This is the character 41 in hexadecimal, which is a capital A. This is a binary 5, which is not a printable character, and so it has to express it this way, by just showing its numerical value. That is something that is certainly confusing at first. If you have a list of hexadecimal bytes, some of them will print in this byte form with the value in hexadecimal, and some will print as printable characters. Right. So we can do the Caesar cipher, one of the famous cryptography systems that was military encryption as of a few hundred BC. So your plain text is hello, and you're just going to shift the letters forward in the alphabet by 3. So for each character in the plain text, which is here, I add it. I take the character and I just add numbers to it and then return it to bytes. So the plain text was a byte array, not a string. So when I take one of the characters from there, one of the H, it interprets that not as the letter H, but as the numerical value of H. And then I can add 3 to it and shift it back to bytes. So I'll get KHOOR, which is H, I, J, K, E, F, G, H. This is each letter moved forward 3 spaces in the alphabet. All right, and you can decrypt it this way with just the same kind of logic. You put in the ciphertext, and now you just subtract the shift and turn it back into bytes. So that'll turn back into hello. All right. All right, and then you got bytes and hex strings. This is how you convert here's a hex string, 48, 65, 6C, 6C, 6F. You could go back to that ASCII table and look these up. Like 48, if you go up here, go back to the ASCII table, this is 48 in hex. And so 48 is a capital H. All right. So that you could look it up in that table one by one, but of course Python will do it for you. If you print these bytes objects, it will turn it into a printable character if it can. So that's going to convert from hex to bytes. This is going to take that series of hex, and it's going to bytes from hex. We'll turn that into bytes. And then I can print it. So in bytes, that is hello, capital H, lowercase ELLO. That's what this is. All right. And here's Waldo in bytes, and when I turn it into a hex string, here it is 57, 41, 4C, and 41 is a capital A, and D is a 44. You can see some of them there. So these are the various ways you can express a variable, and it's good to practice and get used to them. And you will have to play various games with these to find these flags. So that's what I wanted to show you on this one. I'm going to stop this video.